Conclusions. We described two importance sampling techniques for a standard Monte Carlo, MC, method that could enable fast simulation of signals from optical coherence tomography, OCT, imaging systems. These OCT signals are generated due to diffusive reflections from either multilayered or arbitrarily shaped, turbid media, for example, tissue. Such signals typically consist of ballistic and quasi-ballistic components, of scattered photons inside the medium, in addition to photons that undergo multiple scattering. We showed that MC simulation of these OCT signals using our importance sampling reduced its computation time on a serial processor by up to 3 orders of magnitude compared to its corresponding standard implementation. Therefore, our importance sampling techniques enable practical simulation of OCT scans of turbid media, for example, tissue, using commonly available workstations. Introduction. The most common primary intraocular malignancy in adults is choroidal melanoma, accounting for 5% of all melanomas, originating within the pigmented cells of the choroid. More common in Caucasians, the Collaborative Ocular Melanoma Study, COMS, found the mean age at diagnosis to be 60 years. Generally, they are located posterior to the ciliary body and often found during ophthalmic examination. The plaque is temporarily sutured to the sclera overlying the tumor, left in place for 5 to 7 days and then surgically removed. Temporary placement of an episcleral plaque containing radioactive material has gained acceptance as a treatment for choroidal melanoma. Compared to enucleation, eye plaque brachytherapy provides better outcomes for uveal melanoma. The choice of the treatment method is depending on the size and location of the tumor. One of the most common primary intraocular malignancies is the choroidal. Patients with a medium-sized choroidal melanoma, between 2.5 and 10 mm in height and 0. Now we can introduce the perception of local disorder of the K-system property and its measure park. We will say that the K-system property is fully ordered inside the sphere V if all the nodes inside the sphere have the same value of K. Consequently, one can say that the sphere V exhibits some local disorder of K if more values of K are distributed inside the sphere. The measure of the local disorder can be defined by as follows. Which gives park equals 1 if the case of fully ordered system property, slope equals 0. One can see that park decreases when local disorder of K system property increases, slope greater than 0. We assume that local disorder of K system property decreases the probability of cluster growth and constitutes barriers for cluster expansion. Thus, one could expect non-uniform distribution of adding probability pad among the system nodes. In order to derive a reasonable formula for pad, we follow an analogy with derivation of the van der Waals equation. Our ideal gas corresponds to the uniform distribution of adding probability given by Wolf algorithm, while real gas refers to the case when the distribution of adding probability is affected by local disorder of some system property. In order to still play with Wolf algorithm, an influence of local disorder should be compensated in some way, for example, by multiplication pad by park minus 1. Then, assuming that this product satisfies the Wolf's formula pad x slope equals 1 minus x minus 2 beta j, the adding probability that takes into account the impact of local disorder of some system property can be easily obtained. The above equation is the clue of our method, which expresses the decrease of the classical adding probability by the disorder-based factor. A set of property, for which the disorder is determined, by the local information entropy, should be chosen dependently on a specific application. The alpha parameter expresses some enhancement or weakness of the influence of the entropy on the system clusterization. It should be defined regarding the specific problem, see next paragraphs.